All right, so I'm going to take a look at the coffee maker question from 2013. It is the BC problem 4. I decided to take a look at this, or it's BC problem 3 rather, and I wanted to take a look at this one because I figured not everyone might have a calculator. So let's see what we've got going on here. We're given a table with time in minutes, C in ounces, and hot water is dripping through the coffee maker, filling a cup. And we're looking just from time 0 to 6 minutes. It tells us it's differentiable. And now it says use the data in the table to approximate the derivative at 3.5. Show the computations that lead to your answer and indicate units of measure. All right, so when I take a look at this, pay attention to what you're given. So I am given C and T, and it's asking me for the derivative. Very frequently, when they ask you for the derivative and they give you a table, that's asking you to calculate the slope, kind of doing slope that old school way using your average rate of change. Okay, so I would say here that your average rate of change, so you're going to do, it's asking you for 3.5. Notice that 3.5 is not on the table, so I'm going to use t equals 3 and 4. So it would be 12.8, right, your y value minus a y value, over x value minus x value. So it's just your old school slope formula, f of b minus f of a all over b minus a. And here you get 1.6, right, over 1. And so that gives me 1.6, and I'm in ounces per minute. Okay, so this coffee maker is filling up at 1.6 ounces per minute at 3.5 minutes. And let me just make sure I answered the full question. Indicate units of measure, check, check. Okay, so next it says that between 2 and 4, is the derivative equal to 2? Now, be very careful here. This is not an intermediate value problem. Intermediate value would be if they were talking about C, but they're talking about C prime here. So what I would do is say, all right, they're talking about the derivative. There is another theorem that we learned right around the same time as intermediate value theorem, and it's the mean value theorem. Normally, mean value theorems are written in the way where you're calculating the time where, you know, the question says something to the effect of find the value of C guaranteed by the mean value theorem. This is kind of asking it almost in the reverse. So it's saying when is the derivative, or it's saying, you know, can you show that the derivative does equal 2 between this time? So one of the things you need to do before using any of the theorems, whether it's intermediate value theorem or mean value theorem, is kind of state the conditions that say that you're allowed to use it. And the key word up here is differentiable. So remember that if something is differentiable, okay, differentiable implies that it is continuous. Okay, so since this is continuous over this closed interval from 0 to 6, I can apply the mean value theorem. And I'm going to say that means from 2 to 4 that we're going to use this and this. So we're going to say 12.8 minus 8.8 over 4 minus 2. Well, that gives me 4 over 2, which equals 2. All right. And that's exactly what I was trying to show there. So I think a key there to get your point would be that you'd have to say that differentiability implies continuity. So you then I'd say something like by mean value theorem. Okay. So I need to scooch up a little bit there. Okay. So we've got that for part B. All right. Now let's take a look at part C. So in part C here, use the midpoint sum with 3 subintervals of equal length indicated by the data. All right, and okay, well, if I'm using this integral here, that's my average value. So I'm really calculating the average value of the amount in the cup, right? So as far as explain the context, okay, using correct units, if I'm integrating the change here, then I'm going back to ounces. So that means that I'm going to find the average amount of ounces in the cup over the time period 0 to 6. And now I need to use my midpoint to approximate it. So I'd probably maybe even going back up to the table. Remember, your midpoint, you're breaking this up into 3 subintervals. So you're going to go from 0 to 2, 2 to 4, and 4 to 6. And since it's asking you to use the midpoint, we're going to be using that 5.3, 12.8, 11.2, and this 13.8, not this one, sorry. Those will be my heights. And the base of each of these rectangles, it's consistent, it's 2. So for your midpoint, I'd say something like 2 times the 5.3 plus 2 times the 11.2 plus 2 times 13.8. That's going to be your midpoint. And remember, we're kind of plugging that in to here. So we'll say the integral from 0 to 6. And then that 1/6 out front is just saying, well, this is how many there are. And then you're dividing it by 6 to get the average value. So this represents the average number of ounces in the cup from t equals 0 to t equals 6. And I would definitely safe stop this. There's a little too much room for error in there for me to want to do this. And this is, again, I'm just making sure I got my units, ounces per cup, so I think I'm good there. All right, so the amount of coffee in the cup in ounces is modeled by, okay, they're giving us a new equation here. Using this model, find the rate at which the amount of coffee in the cup is changing. So if this is the amount in the cup and they're asking me how that is changing, that's asking me to take a derivative. And so I would take a derivative of this. That would give me a general model for how it is changing. And then find the rate when it's changing at t, and then plug in 5. So that's all I would do here. I'm running out of room. Maybe I can fit it at the top here. So I guess I could write it over here. All right, so for part D, take a derivative. So remember, the derivative of 16 is 0, but the derivative of this part, right, you recopy it. Anytime you take the derivative with e, you just recopy it, and be careful, it's a negative 0.4t. So recopy it times the derivative of that exponent. So the derivative of that is a negative 0.4t. So I would say that b prime of t, right, I'm kind of using that notation up there. I should have said this in the beginning. So you could multiply those, but again, I wouldn't risk it since it's some decimals. If you're not comfortable, go ahead and safe stop it. And I would say something like that. And then make sure you answer the full question. It was asking you then to plug in t equals 5. So the derivative evaluated at 5. I'd say negative 0.4 times negative 16, and then e to the negative 0.4 times 5. And again, I think it would probably be to your advantage just to stop right there to collect all of your points. All right, so that is 2013 BC number 3, the coffee. Have a great day.